dear students, welcome to my YouTube channel. Let us learn about the new topic, bending stress and shear stress diagram of rectangular beam. Right? So, first of all, my question is, what is bending stress and what is shear stress? Whenever the bending moment is applied to any particular beam or the shear force is applied to any particular beam, the material of the beam that resists that bending moment as well as the shear force, that resistance is called as bending stress and shear stress. Right? So the bending stress is the internal resistance that is generated within the component when bending moment is applied. Same way, shear stress is what? Shear stress is also the material's internal resistance to the deformation when it is subjected to the shear force. Right? Now, let us draw bending stress and shear stress diagram. For the same, first of all, we should know about maximum bending moment and maximum shear force of any particular beam. Right? This one is, say, simply supported beam with a load of 10 kilonewton per meter. Let us draw bending moment diagram first. So, bending moment diagram of this particular beam. At ends we have 0 bending moment and at center it is 20 into 2 clockwise from this reaction minus, due to this UDL we have 10 into 2 into 1. So the bending moment at center is 20 kilonewton into meter. Right. So the maximum bending moment is 20 kilonewton into meter. Right. Let us now draw the bending moment, bending stress diagram. So here for any particular beam the bending stress is 0 at neutral axis and it is maximum at ends. Now let us draw the diagram. This is our cross section of 200 by 600 mm. Now this is the line of neutral axis. So here is the centroid of this rectangular section. Right? Now let us draw the diagram. So this is what? The distance of the extreme fiber from the centroid of this particular beam. Now let us draw the diagram. This equation that is from the pure bending theory. F upon y is equal to m upon y. F is what? Bending stress. Y bar is what? The distance from the neutral axis of this extreme fiber. M is the maximum bending moment and I is the moment of inertia. Now let us determine the bending stress F. Right? So bending stress is maximum at ends and 0 at neutral axis. Now next, let us draw the diagram. This is our cross section. Now this is the equation from theory of pure bending. F upon y is equal to m upon y. Maximum bending moment already we have derived, it is 20 kilonewton into meter. And y bar, that is the distance from neutral axis, so it is 600 by 2 is equal to 300 mm. I is equal to BD cube by 12, that is 5.4 into 10 raised to 9. Right, now from this equation, m into y divided by I. F is equal to m into y divided by y. Here in this case, YA and YB both are same because our section is just rectangular section. So distance from the neutral axis to the top fiber and bottom fiber are same. So we have same value of bending stress at top fiber and bottom fiber. So at top fiber 1.11 and at bottom fiber it is also 1.11. When the load is applied downwards, the top fiber that is in compression and bottom fiber it is in tension. So C for compression and T for tension. Right? So here top fiber it is in compression. So here the compression is say positive and the tension is negative. At neutral axis bending stress is 0. Over here that is 1.11 maximum and over here it is also 1.11 maximum. But here we have compression and here we have tension. At top fiber we have compression, at bottom fiber we have tension. So these are the values of bending stress and this is the bending stress diagram. Now let us draw shear stress diagram. For the same we have to plot the shear force diagram. So for this particular beam, shear force diagram is this: 20 kilonewton up, over here it is 0 and 20 kilonewton down. So the maximum bending moment, the maximum shear force value is 20 kilonewton. Right? Now let us draw the shear stress diagram. Remember the shear stress is 0 at ends and maximum at meet span. Exactly opposite to the bending stress. At ends we have 0 and at neutral axis we have maximum value of shear stress. Now let us draw the shear stress diagram. Now this is our cross section, this is a neutral axis. Now the equation for shear stress, it is S A y bar upon IB. How to determine S, that is the maximum shear force, it is 20 kilonewton, so 20 into 10 raised to 3 Newton. AY bar, that is what? This is our centroid, right? And our section is of 300 by 300, right? Either you have to consider the top portion or you can consider the bottom portion, both are the same. So 300 into 300, the half, exactly half of this, multiply by 300, that is what? That is what? That is the distance from neutral axis, right? So the distance from neutral axis is also 300. So our AY bar, that is equal to distance from centroid to either top fiber or bottom fiber, because both are same, right? It is 27 into 10 raised to 6. And I is equal to same way BT cube by 12. So this is the value of moment of inertia, right? And from that we determine S or shear stress at the center, that is what? 3.34 Newton per mm square. Putting all these values, shear stress, AY bar, I, that is moment of inertia, B, that is the width of cross section, and that is 300 mm, right? Putting all this value, we will get S is equal to 3.34 Newton per mm square. Hope my dear student, it is clear how to plot shear force and bending shear stress and bending stress diagram, right? So if you have any query, any question, you can mail me, and please don't forget to like, share and subscribe. So thank you for watching.